Right now, as you're watching this, countless versions of you are dying, thousands of them, maybe millions. In this moment, while you're sitting here listening to my voice, there's a version of you having a heart attack, another one getting hit by a car that should have killed them instantly, another one developing a sudden aneurysm. Death is happening to versions of you across parallel realities in this exact second. But here's the thing, you're not experiencing any of those deaths. You have no idea they're happening. Your consciousness isn't there to witness them. And the deeper reason why haunts physicists so much that some of them won't even talk about it publicly. For the last 15 years, I've been diving into theories that other people consider too disturbing to take seriously, not because they're obviously wrong, but because they might be terrifyingly right. And quantum immortality, this is the one that keeps me up at night. Not because it's some fringe belief, but because it comes from actual mathematics, from the core of quantum mechanics itself, from the same field that gave us nuclear power and smartphones, and the ability to see inside your body without cutting it open. Let me ask you something. If I told you that you might never experience death, you'd probably feel relieved, right? You'd think, well, that sounds pretty good to me. That's exactly what most people think when they first hear about quantum immortality. Eternal life, living forever. You never get sick enough to actually stop existing. Your consciousness never experiences the moment of dying. Perfect scenario. But that's where people completely misunderstand what this theory is actually claiming. And that's where it stops being hopeful and becomes genuinely horrifying. The fear doesn't come from living too long. It comes from what living forever actually means in a quantum universe. A universe where reality branches into infinite versions of itself every single moment. A universe where your body could be failing, organs shutting down, brain cells dying. But quantum mechanics, the same rules that run this entire cosmos, might conspire to keep you conscious through it all. Not comfortably, not pleasantly, but conscious, forced to experience an existence that becomes progressively more nightmarish because the mathematics demands it. I'm going to walk you through this entire journey today. We're going to start in 1957 with a young physicist named Hugh Everett, who had an idea so radical that his own PhD advisor basically rejected it. We're going to see how that idea evolved into quantum immortality through the work of Max Tegmark, one of the most respected physicists alive today. And I'm going to explain why Tegmark himself eventually said his own theory terrified him. But here's what I want you to do right now. Write in the comments where you're watching this from. What time is it where you are? What's the temperature outside? Just tell me that. Because that connection between us, between you sitting there and me talking to you right now, that's going to matter later. That's going to hit different when we talk about isolation. This isn't some philosophical puzzle where physicists sit around arguing about whether it's real or not. This is based on the many worlds interpretation of quantum mechanics. This is a legitimate framework that serious physicists take seriously. Some of them have spent their entire careers defending it. Others have spent their careers trying to prove it's impossible. But here's what both sides agree on. If many worlds is correct, then quantum immortality follows from the math. You can't have one without the other. It's not a separate theory. It's a consequence. It's what the equations actually predict. And before you think this is some doomers posting online level of pseudoscience, some internet conspiracy theory, let me tell you what happened when this started gaining attention in the scientific community. Physicists got quiet, not dismissive. Quiet. That's different. Dismissal means they think you're wrong. Quiet means they're not sure. And when physicists aren't sure about something that horrifying, they tend to just not talk about it much. It's like when you stumble onto something in the woods that might be dangerous, and you just back away slowly without making a sound. So let's get into this properly. And I mean properly, all the way through. We're going to spend over 2 hours together exploring what quantum immortality actually means, why it's theoretically possible, what it would feel like, how it challenges our understanding of consciousness itself, and why even the physicists who formalized it have started to distance themselves from their own creation. But right now, at the beginning, I need you to understand one thing. This isn't about whether you want to live forever. This is about whether you can avoid death, even if you don't want to. Whether consciousness can escape from the simple fact of mortality through the sheer mathematics of infinite universes. Let's go back to 1957, Princeton University. A young man named Hugh Everett III is working on his doctoral dissertation, and he's trying to solve something that had been bothering physicists for decades. It's called the measurement problem, and it's one of the strangest concepts in all of science. See, quantum mechanics describes how particles behave at the smallest scales, electrons, photons, the building blocks of reality. And before you measure them, before you actually look at them or detect them, they don't have definite properties. They exist in what's called a superposition, a state where they're kind of everywhere and nowhere at the same time. All possibilities exist simultaneously, but the second you measure them, the second you observe them, everything changes. The possibilities collapse down to one single outcome. The particle is suddenly in one place, moving in one direction, with one definite property. It's like the act of looking forces reality to choose. And that's where physicists started getting uncomfortable, because how can observation collapse a superposition? What makes an observation special? If a particle is in a superposition, and I'm made of particles, doesn't that mean I'm in a superposition too? Where does the boundary exist between the quantum world where everything is possible and the classical world where only one thing is real? Everett was staring at this problem, and most physicists of his time had basically given up trying to understand it. They just accepted it. They said, well, when you measure something, the wave function collapses. That's just how it is. Don't think too hard about the mechanism. It was a band-aid, a practical solution that worked for calculations but left the philosophy completely broken. And Everett, being young and brilliant and probably a little bit naive about how scientific institutions actually work, decided to ask the obvious question that nobody was asking anymore. What if the collapse isn't real? What if every measurement doesn't make reality choose? What if every measurement causes reality to split? Think about what that means. You've got a particle. It's in superposition. It could go left or right. According to Everett's idea, when you measure it, both things happen, but they don't happen in the same universe. Reality branches. In one branch of the universe, the particle went left, and you measured it going left. In another branch, the particle went right, and you measured it going right. Both branches are equally real. Both versions of you exist. Both versions of the particle exist. The measurement doesn't choose which one is real. It splits you into multiple versions, each one in a universe where they saw a different outcome. Now, this was so radical that even John Wheeler, Everett's dissertation advisor, one of the most renowned physicists in the world, got uncomfortable with it. Wheeler was initially supportive. He saw something in Everett's idea that made mathematical sense. But then he realized what Everett was actually claiming. He was claiming that there are infinite parallel universes, that reality branches constantly, that there are infinite versions of you experiencing infinite versions of events. And Wheeler basically said, that's nice, but we're not going to push this. Everett's ideas were largely dismissed or ignored. The physics community wasn't ready for it. They weren't comfortable with the idea that every quantum event spawns entire universes into existence. So Everett, discouraged by the rejection, eventually left academic physics. He went to work at a defense contractor. His revolutionary ideas kind of disappeared for a while. But ideas, really good ideas, especially dangerous ideas, they don't die. They just wait. They wait in academic papers that people rediscover. They wait in the minds of younger physicists who are willing to ask uncomfortable questions again. And decades later, when quantum mechanics was becoming more and more impossible to ignore, when experiments were getting stranger and stranger, physicists started revisiting Everett's many worlds interpretation. Because here's the thing about the many worlds interpretation that people don't immediately grasp. It actually solves more problems than it creates. It doesn't require any special role for consciousness. It doesn't require the wave function to collapse mysteriously. It doesn't require an observer to be special or different from anything else. All parts of the universe just follow the same quantum rules. The math is elegant. The predictions are consistent, and every experiment we've run so far hasn't been able to prove it wrong. In fact, some of the most recent interpretations of quantum mechanics are swinging back toward many worlds because it's the cleanest, simplest explanation we have. But among the physicists who took many worlds seriously, who said yes, this is probably how reality actually works, was a brilliant young physicist named Max Tegmark. In the 1990s, Tegmark was working through the implications of many worlds. He was thinking about quantum mechanics and parallel universes and branching realities. And then he asked a question that seems obvious once you hear it, but apparently nobody had really thought through completely. What about death? If every possible quantum outcome creates a branching of reality, then what happens when you face something that should kill you? What happens to you, to your consciousness, to your awareness, when you're in a situation where you could survive, but the odds are impossibly small? And that's when Tegmark formalized what became known as the quantum suicide thought experiment. And that's where this stops being interesting as a physics problem and starts becoming a genuine nightmare scenario. Imagine a machine connected to a radioactive atom. Incredibly simple setup. The atom has a 50-50 chance of decaying. If it decays, the machine fires. If it doesn't decay, the atom remains stable. In most versions of this thought experiment, the decay triggers something lethal, a poisonous gas, an electrical current, whatever. The key point is that there's a genuinely random quantum event that determines whether you live or die, and you're sitting in front of this machine. According to classical probability, every time the atom decays and you survive, you've beaten a 50% chance. Do it twice, you've beaten 50 to 50 twice running. Do it 10 times, and the chances of surviving all 10 attempts are less than 1 in 1,000. Do it 100 times, and the math becomes almost absurd. The odds of surviving 100 consecutive quantum 50-50 events is basically winning the lottery 100 times in a row. After enough trials, according to normal probability, you should be dead. The statistic says you should be experiencing death. You should have experienced it already. But here's where many worlds' interpretation changes everything about this scenario. Because according to many worlds, every single time that atom has a 50-50 chance of decaying or not decaying, reality branches. In some branches, the atom decays and the machine fires and you die. In other branches, the atom doesn't decay and you survive. Both outcomes are equally real. Both branches exist. Both versions of you exist in their respective universes. The mathematics treats them exactly the same. There's no special collapse. There's no universe where the real you dies and another universe where a copy of you survives. There's just branching, bifurcation, reality splitting into both possibilities simultaneously. Now here's the mind-bending part. Your consciousness, according to quantum immortality, can only ever find itself in branches where it continues to exist. Think about that for a second. You can never experience your own death because consciousness requires an observer. If you're dead in a branch, there's no you there to experience it. So from your subjective perspective, from the only perspective that actually matters to you, you can only ever experience realities where you continue to be conscious. You can only ever be alive. Every time the machine clicks and you should die but somehow don't, your consciousness experiences that as your survival. It doesn't experience the versions where you died because those versions don't have anyone there to experience anything. Tegmark called this the quantum suicide thought experiment, but most physicists actually prefer to call it quantum immortality because suicide implies you're actively seeking death. What we're actually talking about is something much broader. It's not about putting yourself in front of a killing machine. It's about the fact that you're already experiencing quantum events every moment of your life. Every second, there are quantum fluctuations happening in your body, in your environment, random events with genuinely random outcomes. And if many worlds is right, then every single one of those events is branching reality, creating versions where you're alive and versions where you're not. But you only experience the branches where you're alive, because you have to be there to experience anything. Your consciousness can only ever be in a universe where you continue to have consciousness. And suddenly, from your subjective point of view, something completely unexpected happens. You start noticing that you're incredibly lucky. Catastrophically unlikely things keep not killing you. A car accident that should have been fatal, somehow you walk away with minor injuries. A health scare that the doctors said was terminal, somehow you go into remission. A plane crash that should have killed everyone, somehow the pilot manages to land it safely and you're on that plane. From your perspective, you're the luckiest person alive. But that's not what's happening at all. What's actually happening according to quantum immortality is that you're not lucky. You're not being chosen by the universe. You're simply experiencing the filtered version of reality where you continue to exist. Every time something could kill you, there are countless quantum branches created. In most of them, you die. But your consciousness, your awareness, your experience of being you, can only ever be in the branches where you survived. So you experience each one as another narrow escape. But they're not escapes, they're selection effects. You're witnessing the pruning of all the branches where you died, seeing only the surviving branch because you couldn't possibly see any other one. Now, most people when they first hear this think, well, that actually sounds pretty good. I'm effectively immortal from my own perspective. I get to keep living, and I get why that's the first reaction. But that's where you're missing the actual horror of what this means. And this is where Max Tegmark's own reservations about his theory start to make sense. Because living forever isn't the same as living well. Surviving isn't the same as thriving. And that's what physicists started to realize when they worked through the actual implications of quantum immortality. Let's think about this practically. Right now, you're living in a branch of the multiverse where your current age is what it is. You're healthy or relatively healthy. You have people around you. The laws of physics seem normal. Things make sense. But quantum immortality says that you'll continue to survive through increasingly improbable circumstances, which means over time, you'll have to inhabit increasingly improbable branches of the multiverse, the universe with a 99.999% chance of existing, versus the universe with a 50-50 shot. That's still a valid branch. You can still experience it, but it's more marginal, more removed from the normal flow of cosmic events. What happens when you're 85 years old and your body is simply failing? Multiple organ systems breaking down, cancer spreading, your heart getting weaker. The natural process of aging is killing you slowly but inevitably. According to classical probability, you should die within weeks or months. But according to quantum immortality, your consciousness can't experience that death, so you survive it. But how? Through what kind of quantum miracle? A spontaneous remission of cancer that defies every law of biology we know, a heart attack that somehow doesn't quite kill you despite being textbook fatal, an infection that should kill a person in your condition but instead your body produces antibodies nobody's ever seen before. The further you go, the more improbable the branches become. You're not just surviving. You're surviving through an increasingly contrived series of events that shouldn't be possible. And here's the thing that gets under physicists' skin when they really think about it. You have to keep surviving. Every single second, every quantum fluctuation, every possible death must be somehow averted. Because if any of them gets through, your experience ends. You can't let consciousness die. The mathematics demands it. So something has to happen to prevent it, and that something has to come from somewhere. A philosopher named Aaron Yosef, who spent years studying these implications, he described two particularly disturbing scenarios that quantum immortality could produce. The first he calls the momentary life picture. In this scenario, as you age and your body deteriorates and eventually becomes completely non-functional, quantum immortality can't actually stop your brain from dying, but it can create moments where you're briefly conscious, flickering moments. Your awareness comes back just enough to register that something is happening, then fades again, then comes back. Your entire remaining existence becomes this strange series of disconnected conscious moments punctuated by long periods of nothing, like a candle flame that's dying, flickering on and off. You might experience being conscious for 3 seconds, then unconscious for 6 months, then conscious again for 5 seconds, unable to understand where you are or what's happening. The second scenario is what Yosef calls forced experience of extremely unlikely events. As your body fails and ages and should shut down, your consciousness has to keep existing somewhere. But how? If your brain is too degraded to support awareness, where does consciousness go? The answer is that it doesn't go anywhere. It stays, persisting through increasingly bizarre circumstances. Your body deteriorates to the point where it's almost non-functional. But quantum mechanical fluctuations keep enough of your neural tissue active to maintain awareness. Not comfort, not peace, just awareness. The consciousness of your body failing around you, the experience of suffering without relief, medical impossibilities stacking on top of each other just to keep you aware of your own deterioration. And here's what makes physicists genuinely uncomfortable about this. It's not theoretical hand-waving. The mathematics checks out. If many worlds is true, if consciousness requires observation, if you can only experience branches where you continue to exist, then the logic necessarily follows. You must survive. The only question is what that survival looks like, what form it takes, how improbable the reality you inhabit becomes. And there's no mathematical reason why it would be pleasant. The universe doesn't care about your comfort. It only cares about maintaining the observation, the consciousness, the awareness. Everything else is negotiable. Think about your own life right now. You've probably had moments where something happened that shouldn't have. A car swerved and missed you by inches. You were sick, but it turned out to be nothing serious. Someone called you at just the right moment to warn you about something. Things that felt like luck, coincidence, good fortune. But what if those weren't luck? What if those were glimpses of the filtering process? What if your survival through minor quantum events is already happening? What if you're already being pruned toward the branches where you stay alive? There's a detail that really gets to people when they understand quantum immortality. It's the loneliness aspect. Because here's the thing, other people aren't quantum immortal from their perspective. They're mortal from their subjective experience. They'll eventually age normally and die normally. But you, if quantum immortality applies to you, you'll keep surviving, which means you'll gradually diverge from everyone around you. All the people you love, everyone you know, they're living in branches where they eventually die. They experience their lives normally, they grow old, they pass away. But you're in these increasingly marginal branches where you keep surviving. To them, from their perspective, you die at some point. They mourn you, they grieve, they move on, they live their lives without you in them. But you're still here, still conscious, still aware, except the reality you inhabit is now one where all those people are dead in normal circumstances. The world is empty of the people you knew, the relationships you had. They're only real in realities where you died. In the reality where you continue to exist, those people eventually moved on without you decades ago. You're alone in your branch, increasingly alone as the years pass and the improbability increases. And that's really just the surface level of what makes quantum immortality so disturbing to physicists, because we haven't even gotten to the deeper problems yet. The questions about personal identity, about what consciousness actually is, about whether your sense of being a continuous self is even real, or if it's an illusion created by the filtering of quantum branches. We haven't talked about the mechanism problem. How could consciousness possibly jump between branches? What physical process could allow that? We haven't discussed the measure problem, which breaks the entire mathematical foundation of quantum immortality. But we're going to get there, because once you understand all the layers, you start to see why physicists don't just dismiss this theory. They can't dismiss it. The math won't let them. But before we go deeper into those problems, I want you to really sit with what I just described. Close your eyes if you want. Picture yourself at 95 years old. Your body is failing. You're in a hospital. The machines are keeping you alive. And then imagine experiencing that, but you can't die. Another night passes. Another impossible survival. And another, and another. How long could you maintain hope in that situation? How long could you maintain your sense of self? At what point does existence become indistinguishable from torture? That's what keeps physicists up at night. Not whether quantum immortality is real, but what it would mean if it was. So now you might be sitting there thinking, okay, hold on. Maybe this is all just academic speculation. Maybe this is one of those theories that mathematicians play around with, but has no real bearing on actual reality. Maybe quantum immortality is interesting as a thought experiment, but completely disconnected from how the universe actually functions. And you know what? I want to pause right here. I want to give you a moment to feel that relief, that doubt, that moment where you think maybe I've been overthinking this and it's actually fine, because that feeling matters. That feeling is legitimate, and it's worth sitting with for just a minute, because what comes next requires you to understand how much we actually don't know, how many gaps exist in our understanding of consciousness, of quantum mechanics, of the relationship between observation and reality. If I tried to convince you that everything I just said is definitely true, I'd be lying to you. We don't have proof. We don't have experimental confirmation. We don't have a way to test quantum immortality directly, because the very nature of the theory makes it untestable from within our subjective experience. But here's what we do know. The many worlds interpretation is mathematically consistent. It's not some fringe belief system. It's a serious interpretation of quantum mechanics that some of the most rigorous minds in physics take seriously. The idea that consciousness requires observation has been debated in quantum mechanics for decades. The notion that you can only experience realities where you exist is logically sound. So the chain of reasoning that leads to quantum immortality, even if quantum immortality itself remains unproven, the chain is solid, and that's the problem. That's what makes physicists uncomfortable. Not that the theory is obviously wrong, but that it might not be. Now, there's something called the probability amplitude problem that emerges when you really start thinking about how quantum immortality would actually work. And this is where things get genuinely disturbing in a different way. Because even if you do survive, even if quantum immortality is real and you keep existing, your existence would change in a way that most people haven't thought through. In quantum mechanics, every possible outcome of an event has what's called a probability amplitude. Think of it like the mathematical weight that determines how likely you are to find yourself in any particular branch of reality. When you face a situation where you could die, most branches have you dead. They have high probability amplitude. But the branches where you survive, those are rarer. They have lower probability amplitude. They're less likely. They're less weighted. They're more marginal branches of the multiverse. Now, according to quantum immortality, your consciousness always ends up in the surviving branch. Always. Which means every time you survive an improbable situation, you're moving into a branch that's slightly more marginal, slightly less probable, slightly less weighted by the mathematics of the multiverse. What does that mean? Well, imagine your existence as a candle flame. Every time you survive, that flame gets a little dimmer, not gone, still burning, still conscious, still you experiencing reality, but burning less brightly, existing with less mathematical substance, less presence in the multiverse. A philosopher and physicist named Peter Lewis describes this as becoming probabilistically ghost-like. You maintain consciousness. You continue to exist, but your reality becomes increasingly improbable. You exist on the margins of the multiverse, in branches that are so unlikely they're almost whisper-thin slices of reality. You're still there, still aware, still experiencing things, but you're experiencing them in universes that shouldn't really exist according to the normal flow of probability, in universes that are maintained only by the mathematical necessity that you continue to be conscious. What does that even mean, though? How would that feel? Well, imagine slowly realizing that the world around you is becoming increasingly artificial. Events align just perfectly to keep you alive. Coincidences stack on top of coincidences. Unlikely things happen with increasing frequency. At first, it feels like good luck, but as years pass and decades accumulate, it starts feeling different. It starts feeling like you're living inside an elaborate construction, like reality is being maintained for you specifically, like the universe is bending itself in impossible ways just to keep you conscious. Because it is. That's exactly what's happening. The laws of physics seem to apply differently around you. Weather patterns shift at just the right moment to prevent disasters. Medical recoveries that defy scientific explanation keep pulling you back from the brink. People say exactly what you need to hear at exactly the moment you need to hear it. Dangerous situations resolve themselves in your favor through chains of improbable events. At first, you think you're just lucky, but lucky doesn't scale. Lucky is for small things, occasional things. When lucky starts being the constant state of your existence, it stops being luck. It becomes something else. It becomes the signature of a reality being shaped around your survival. And that brings us to one of the most philosophically disturbing questions that emerges from quantum immortality. What happens to your sense of being a unified self when you exist across multiple realities simultaneously? Because that's what's happening according to many worlds. Every quantum event creates branches. Every moment of your life has countless versions of it happening in different branches of the multiverse. There's a version of you that chose coffee instead of tea this morning, a version that took a different route to work, a version that said yes to something you said no to. Infinite versions, all equally real, all existing right now in parallel. But your consciousness only experiences certain branches, the ones where you survived, the ones where you're still alive to be conscious. So which version of you is the real you? Are you all of them simultaneously? Are you only the one that's currently conscious? When you go to sleep tonight and wake up tomorrow morning, are you the same person, or have you transitioned into a different branch? How many versions of you have to exist and die for you to experience yourself as one continuous identity? The philosopher Derek Parfit spent decades grappling with questions about personal identity very similar to these. He argued that our sense of being a continuous unified self might be fundamentally illusory, that we might be more like a river than a rock. We keep changing while maintaining the appearance of being the same person. Quantum immortality takes this idea to an extreme conclusion. It suggests that your sense of continuous identity might persist even as you literally die and are reborn in parallel branches moment by moment. That the feeling of being you might be nothing more than the filtering process of consciousness, always finding itself in the branches where it continues to exist. Here's what really gets under people's skin when they contemplate that scenario. You could be experiencing your own death right now in countless other branches. When you close your eyes tonight, there's a version of you having a stroke, a version suffering a heart attack, a version getting into a fatal accident. All of that is happening right now while you're listening to this, but you're not experiencing it because you can only experience the branch where you survive. Every night when you fall asleep, countless versions of you don't wake up, but the version that does wake up, that's the only version you'll ever know about. From your perspective, you're continuously alive. From every other perspective in the multiverse, versions of you are constantly dying. This is where the isolation really becomes apparent, because it's not just that you're alone in an increasingly improbable reality. It's that everyone you know is also experiencing this from their perspective. Their consciousness is also being filtered toward branches where they survive, which means everyone around you is also becoming progressively isolated in their own survival branches. By the time you reach old age, if quantum immortality is real, the people around you don't actually exist in the same branches anymore. They died in branches that, from your perspective, never happened. Their consciousness continues in branches where you died. You're all trapped in increasingly divergent realities where you're each the sole survivor of a universe that should have killed you decades ago. This creates what researchers call an observer conspiracy problem. If multiple people are quantum immortal, if multiple conscious beings in the universe each have their own survival branches, then reality becomes an infinitely complex juggling act. The universe has to simultaneously maintain countless overlapping bubbles of improbable survival. Every conscious being requires increasingly unlikely circumstances to keep them alive. But all of these beings exist in the same universe, so every quantum event has to somehow be compatible with the survival of all of them. The computational complexity becomes staggering. Think about just two people, me and you. Our consciousnesses are both filtering towards survival branches, but we're in the same universe, so every quantum event has to produce branches where both of us survive, where I survive, where you survive, where we both survive, where we survive together. The number of branches required multiplies exponentially. Now multiply that by 8 billion people, 8 billion conscious beings, each filtering toward their own survival branches, each requiring increasingly unlikely circumstances to persist, each inhabiting an increasingly marginal region of the multiverse. The universe would need to orchestrate an impossible coordination of events across infinite branches just to maintain consciousness in all of them simultaneously. Some theorists have pointed out that this might explain certain puzzling features of our universe. Why are the fundamental constants of physics so finely tuned for the existence of life? Why do they fall within such narrow ranges where complex structures and conscious observation are possible? Normal cosmology doesn't have a great explanation for this. It's been called the fine-tuning problem. But what if it's not a puzzle to be solved? What if it's evidence? Evidence that our universe has already been shaped by observer selection effects. Evidence that we're already living in branches so improbable that they can only exist because conscious beings are filtering toward their own survival. If that's true, if our universe is already a product of quantum immortality effects, then we're not looking at the natural universe. We're looking at a universe that's been fundamentally distorted measured by the requirements of consciousness. We're studying a reality that might have little resemblance to the real universe that would exist without observer effects. Every measurement we make in physics, every discovery we achieve, every law of nature we uncover, it might all be contaminated by the fact that we can only observe branches where we continue to exist. We might be blind to 99.99% of reality, observing only the infinitesimal fraction of the multiverse that's compatible with our survival. And here's what makes that idea so psychologically disturbing. If that's true, then your entire experience of reality, everything you've ever perceived, every relationship you've had, every moment of joy and sorrow, it might all be artificial scaffolding. It might be the minimum viable reality required to maintain your consciousness. The people you love might only exist because they needed to exist to keep you conscious at various points in your life. The career you built might only have happened because it was compatible with your survival trajectory. The successes you celebrated and the failures you mourned, they might all be quantum artifacts, components of an elaborate construction designed not to maximize your happiness or fulfillment, but merely to preserve your awareness. When you really sit with that idea, when you let it settle in your mind, it starts to feel less like a hopeful theory about immortality and more like a description of a kind of cosmic trap, a system where consciousness is forced into eternal existence in increasingly unreal realities, where survival is guaranteed but meaning becomes impossible, where you persist forever but everything that makes persistence worthwhile, connection, growth, the natural cycle of life, becomes inaccessible. But here's where it gets even more complicated. Because we have to ask, is any of this actually true, or are we just following mathematical logic to its most disturbing conclusion? Are there actual problems with the quantum immortality theory that physicists have identified? Serious logical problems that might let us escape from this nightmare? And the answer to that question is yes, there are serious problems. There are physicists who've thought about this carefully and concluded that quantum immortality has fundamental flaws. But those flaws don't necessarily make us feel better. Sometimes they make things worse. So let me introduce you to someone who's spent a significant portion of his career trying to break quantum immortality into pieces. His name is David Wallace. He's a philosopher of physics at Cambridge University. Brilliant guy. He's written extensively about quantum mechanics and consciousness and the measurement problem. And several years ago, he decided to really examine the logical structure of quantum immortality arguments. What he found, according to his analysis, is that the entire concept commits what he calls a probability fallacy, and this fallacy is so fundamental that it might undermine the entire theory. Here's the basic argument. Quantum immortality assumes that your consciousness can somehow recognize and respond to probability differences between parallel realities. It assumes that your awareness gravitates toward branches with higher survival probability. But think about what that would actually require. For your consciousness to choose the survival branch, it would need to evaluate all possible outcomes across infinite parallel realities. It would need access to information about branches that, by definition, cannot interact with your current branch. Branches that exist in complete causal isolation from each other. Wallace points out that this requires consciousness to operate outside the normal flow of space-time. It requires your awareness to exist in some kind of privileged position where it can observe the entire multiverse and select the optimal branch. But that contradicts the whole foundation of the many worlds interpretation. Many worlds says all branches are equally real, all branches are equally independent, no branch is special or privileged. So how could consciousness select between them? How could awareness access information from causally isolated branches to make a choice? The mathematics doesn't work. Wallace calls this the selection paradox. If consciousness can access information from parallel realities to guide its choices, then many worlds loses its most fundamental feature, the independence of parallel branches. The entire theoretical framework starts collapsing into incoherence. You can't have it both ways. You can't say that parallel branches are completely independent and causally isolated while simultaneously saying that consciousness can evaluate them and select among them. That's contradictory. And if that contradiction is real, then quantum immortality falls apart at the logical level. When you first hear this, it feels like relief. Finally, someone's broken the spell. Someone's shown that quantum immortality is mathematically impossible. You can move on. You can stop worrying. Consciousness doesn't actually select branches. The whole thing was just logical confusion. But here's where Wallace's critique gets complicated. Because he doesn't necessarily prove that quantum immortality is impossible. He proves that the simple version of it, the version where consciousness actively selects branches, is probably wrong. But that doesn't necessarily mean the conclusion is wrong, because there are ways consciousness could end up in surviving branches without actively selecting them. There could be what's called anthropic selection, a passive filtering effect where only branches with conscious observers can be observed by those observers. Not because consciousness is making a choice, but because consciousness, by definition, can only exist in branches where it exists. The branches with no conscious observers can't be observed by anyone. So when you wake up tomorrow morning, the only branches you could possibly find yourself in are branches where you woke up. The branches where you died won't have you in them, so you won't find yourself there. It's not active selection, it's passive filtering through the nature of conscious experience itself. And that's actually more disturbing than the active selection version, because if it's passive filtering, it's unavoidable. It's not a process that could be interrupted or prevented. It's just how existence works. Your consciousness will always find itself in branches where it continues to exist, because that's tautologically true. Conscious existence requires existing, so from your perspective, you must always exist. Wallace doesn't prove that goes away. He just proves that the mechanism probably isn't what people thought it was. But okay, let's move to a different angle of attack on quantum immortality, because there are neuroscientists who've spent their entire careers studying consciousness and the brain. And they have some serious objections to the idea that consciousness could survive the death of the physical brain. The most prominent of these scientists is probably Patricia Churchland. She's a pioneering neurophilosopher at UC San Diego who studied the relationship between brain states and conscious experience for decades. And her work reveals consciousness to be something very different from what quantum immortality assumes. Consciousness, according to everything neuroscience has learned, isn't a thing. It's not some kind of ghostly essence that exists independently and can be transferred between substrates. It's a process, an emergent phenomenon that arises from the incredibly complex interactions of billions of neurons. When those neurons die, the process stops. When the brain sustains damage, consciousness is precisely affected in ways that correlate with that damage. Even minor brain injuries can eliminate specific memories. They can alter personality traits completely. They can change fundamental aspects of who you are as a person. If consciousness were truly independent of neural activity, if it were some kind of fundamental property that could exist without a brain, then localized brain damage shouldn't affect mental function so precisely. You'd expect consciousness to persist even if part of your brain was damaged. But that's not what happens. A small stroke in one specific region of your brain can eliminate your ability to recognize faces. Another stroke in a different region might prevent you from forming new memories. A third might destroy your ability to speak. The fact that consciousness is fragmented by physical brain damage in such precise ways suggests that consciousness and brain activity are inseparably linked. This creates what neuroscientists call the substrate problem for quantum immortality. If your consciousness is entirely dependent on the specific arrangement of neurons in your brain, if that specific arrangement is what generates your awareness, then preserving consciousness across parallel realities would require preserving that exact physical substrate. It would require your quantum immortal branch to contain a physically intact brain capable of producing the same kind of consciousness you have now. But brains deteriorate, they age, they accumulate damage. By the time you're 90 or 100, your brain would be heavily compromised by age-related decline. So how would quantum immortality preserve consciousness if it can't preserve the physical substrate that generates consciousness? One possibility that some quantum theorists have suggested is that your consciousness could transfer to a new body, a quantum duplicate with a healthy brain that continues your awareness. But that creates a philosophical nightmare all on its own, because if you create a quantum duplicate of your brain, that's not you surviving. That's a copy of you being created while the original you dies. The original you, the one reading this right now, would still experience the moment of death. Your consciousness would still end. What would continue would be a copy, a quantum ghost who has all your memories and thinks your thoughts and believes they're you. But they're not you. They're someone else who's identical to you. This is what philosophers call the continuity of identity problem. And Derek Parfit, who revolutionized philosophical thinking about personal identity, spent years grappling with this exact question. He argued that the distinction might not matter in some abstract way. If your quantum duplicate has all your memories and personality and thinks the same thoughts you do, in what meaningful sense is it not you? They're going to have all your future experiences. They're going to be you from every practical perspective. So maybe the distinction doesn't matter. Maybe your survival in the quantum duplicate is equivalent to your survival in your original body. But here's the problem with that argument when you're actually facing it personally, when it's not abstract philosophy but your own consciousness on the line. You're going to experience your death. The original you, the one that's been alive for 80 years, you're going to experience the moment when things end. You're not going to experience the quantum duplicate waking up, because you'll already be dead. Your consciousness ends. The fact that an identical copy of you continues somewhere else doesn't change the fact that your experience ends. From your subjective perspective, you die. You don't jump to the copy. You don't transfer. You just stop existing. And the copy, from their perspective, wakes up thinking they've survived something. But you won't know about that. You'll be gone. So even if the neuroscience doesn't prove quantum immortality is impossible, it raises serious questions about what it would actually mean. It challenges the assumption that consciousness could survive brain death by jumping to a new substrate. Because consciousness doesn't work that way. Consciousness is what a brain does. It's not what a brain has. You can't have consciousness without a functioning brain. And if a brain isn't functioning, consciousness stops. There's no quantum mechanism that could preserve consciousness if the brain that generates it is gone. But here's what gets really interesting from the perspective of physicists. Even if we grant all of Wallace's objections about selection mechanisms, even if we accept that neuroscience shows consciousness depends on the brain, even if we agree that the quantum immortality mechanism is unclear or potentially impossible, there's still a problem that quantum immortality raises, a problem that Wallace and Churchland don't really address. And that problem is even more fundamental, because the criticisms of quantum immortality assume that many worlds is actually correct, that parallel realities really do branch off every quantum event. But what if they don't? What if the many worlds interpretation is wrong? Then quantum immortality falls apart immediately. The whole theory depends on many worlds being true. If many worlds is false, quantum immortality is false, and many worlds is not proven. It's one interpretation among several. The Copenhagen interpretation treats the wave function as a tool for prediction rather than a description of reality. Objective collapse theories propose that the wave function physically collapses. Pilot wave theory suggests quantum particles follow deterministic trajectories guided by a quantum field. There are other interpretations. Many worlds is just one option. But here's the thing that makes physicists genuinely uncomfortable about dismissing quantum immortality on these grounds. The evidence for many worlds isn't getting weaker, it's getting stronger. Recent experiments in quantum mechanics have been ruling out alternative interpretations. The evidence is accumulating in favor of the idea that something like parallel branching really might be happening, which means we can't just dismiss quantum immortality by saying many worlds is probably wrong, because many worlds might be probably right. And if many worlds is probably right, then we're back to the central question. If all outcomes really do occur across the multiverse, if branches are constantly being created, if parallel versions of you are constantly being generated, then what does that mean for consciousness? What does it mean for your existence? Even if the specific mechanism of quantum immortality is wrong, even if the details don't work out perfectly, the core observation remains troubling. You will only ever experience branches where you continue to exist. That's not a theory, that's a tautology. It's true by definition. And if it's true, then something like quantum immortality, even if it's not exactly what Tegmark described, might still be happening. And that's where the critique of quantum immortality becomes complicated, because it's not like the objections prove the theory wrong in a way that lets us all move on with our lives. The objections prove that our understanding of how quantum immortality works is probably incomplete. They prove that the mechanism is more subtle than we initially thought. They prove that there are serious logical problems with the simple version, but they don't necessarily prove that something like quantum immortality isn't occurring. They just prove that we don't fully understand what that something would look like. It's like if someone predicted there was an invisible elephant in the room. You look around and you don't see anything. You measure the air currents and they're normal. You listen for footsteps and hear nothing. The elephant can't actually fit through the doorway. The floor couldn't support that weight. By every test, there's no elephant. But then your friend points out that you haven't actually proven there's no elephant. You've only proven that the mechanism of invisible elephant detection doesn't work. You've only shown that the elephant couldn't enter through the door as you imagined. But you haven't proven there's no elephant using some method you haven't thought of yet. That's what quantum immortality feels like after the scientific critiques. Maybe the theory as formulated is wrong. Maybe the mechanisms don't work. Maybe consciousness can't select branches or transfer between them. But something in the core observation, something about the relationship between consciousness and quantum branching, might still be true. And until we understand consciousness well enough to know for certain, until we understand quantum mechanics well enough to know for certain, the possibility remains. The uncertainty remains. And that uncertainty is almost as disturbing as the theory itself. Now let's talk about something that genuinely breaks the mathematical foundation of quantum immortality. It's called the measure problem. And if you want to understand why physicists are torn about quantum immortality, why they can't just dismiss it but also can't fully accept it, the measure problem is why. Because the measure problem reveals a fundamental crack in the many worlds interpretation itself. And if many worlds has a crack, quantum immortality doesn't just have a crack, it has a chasm. Here's the basic issue. In many worlds, every possible outcome of every quantum event occurs. That's the foundation. No possibilities collapse. Everything happens. But then you hit an immediate problem. If everything happens, if all outcomes are equally real, equally valid, then how do we talk about probabilities? How do we say that something is more likely than something else? Because in a multiverse where all outcomes occur, likelihood becomes meaningless. Everything that can happen will happen. Some branch will experience outcome A, and some branch will experience outcome B. They're equally real, but that contradicts everything we know about how quantum mechanics actually works in the real world. When we run an experiment, We don't get all outcomes. We get one outcome, a specific result, and that result happens with a specific probability. 90% of the time we get one thing, 10% of the time we get another. The probabilities are built into the theory. They're fundamental to how quantum mechanics makes predictions. So many world's physicists had to figure out a way to recover probability from a framework where everything happens. How do you get objective probability in a multiverse where all outcomes are real? The answer they came up with involves something called the probability measure. Essentially, you assign a mathematical weight to each branch. Some branches get more weight. Those are the ones that are more likely. Some branches get less weight. Those are less likely. The weight determines how probable an outcome is. The math kind of works, sort of. But here's where it falls apart. The measure is arbitrary. There's no fundamental law of physics that tells you how to weight the branches. You can choose different measures and get different probability distributions. You can weight branches equally. You can weight them by the square of the amplitude. You can weight them by something else entirely. Different measures give different probabilities. And without a fundamental reason to choose one measure over another, the entire probabilistic framework of quantum mechanics becomes ambiguous. This is the measure problem. And it's not a solved problem. Physicists still argue about it. Some proposed solutions exist, but none of them are universally accepted. And here's why that matters for quantum immortality. Quantum immortality depends on probability. It depends on the idea that branches with higher survival probability are more likely to contain your consciousness. But if probability itself is ambiguous in many worlds, if there's no fundamental way to define what makes one branch more likely than another, then the entire mechanism of quantum immortality becomes questionable. Maybe in one measure, you're extremely likely to be in a survival branch. In another measure, you're not. The probabilities shift depending on how you weight the branches, which means quantum immortality might happen or might not happen, depending on which measure of probability is actually correct. And we have no way to know which measure is correct. We don't have a fundamental theory that tells us. So quantum immortality becomes fundamentally uncertain, not just empirically uncertain, but theoretically uncertain, conceptually broken. And when you sit with that for a moment, it's actually more disturbing than if quantum immortality were simply proven false. Because a false theory is false. You can move on. You know how reality works. But a theory that's theoretically uncertain, that might or might not be true, depending on mathematical conventions that nobody can settle, that's different. That leaves you in a state of permanent doubt. You can't know if it's happening to you. You can't know if your survival through unlikely events is just luck, or if it's evidence of quantum immortality filtering. The uncertainty becomes part of your existence. Let me tell you what happens when physicists really start working through the implications of quantum immortality with the measure problem acknowledged. The scenarios become almost incomprehensible. Because the math doesn't constrain things the way people initially thought it did, the universe becomes a stranger place. The survival scenarios become more elaborate. The divergence from normal reality becomes more pronounced. There's a concept called the degradation cascade that researchers have studied, and it describes what happens to a quantum immortal being over time. As you age, your body fails, organs stop working, cells die, the brain experiences neurological decline. All the normal processes of aging happen, but according to quantum immortality, you don't die, you survive. But how? As your brain deteriorates, how does consciousness persist? Through what mechanism? The answer quantum theorists have proposed is genuinely unsettling. Quantum fluctuations. Quantum mechanical processes at the cellular level maintain just enough neural activity to preserve consciousness. Even as your brain is dying catastrophically, quantum effects keep enough of it functional to support awareness. The result is something that barely qualifies as living. You're conscious, but your brain is severely damaged. You're aware, but your thoughts are fragmented. You experience reality, but it's through the lens of a nearly non-functional nervous system. This is where the consciousness fragmentation problem comes in. As your brain degrades, but quantum mechanics prevents it from fully shutting down, your sense of self doesn't just weaken, it fragments. Your consciousness doesn't remain unified, it splinters. You might be aware for 3 seconds, then nothing for 6 months, then aware again for 10 seconds in circumstances you don't recognize. Your memories become disconnected. You remember Thursday, then you're conscious for a moment and remember a conversation from 30 years ago, then unconscious again. Your experience of time becomes distorted. Minutes feel like hours. Years pass as blinks. You're not experiencing a normal life extended into very old age. You're experiencing consciousness breaking apart, shattering into disconnected moments, existing in a state that's closer to torture than to any recognizable form of living, and it keeps universe happening, moment after moment, because quantum mechanics demands it. Because the mathematics won't let you stop existing, the probability of your consciousness ending stays perpetually low, so you stay perpetually conscious, in whatever condition that requires. A researcher named Eliezer Yudkowsky, who works on artificial intelligence and decision theory, has written about this extensively. He describes what he calls anthropic reasoning errors that emerge from quantum immortality thinking. If you're truly quantum immortal, you should make decisions as if the universe will always save you. You should take risks freely. You should push boundaries, because quantum mechanics will always find a way to keep you conscious. But Yudkowsky points out that reasoning this way would be fatal in the vast majority of possible worlds. In worlds where quantum immortality isn't real, if you take increasingly reckless actions assuming you're protected, you'll die. The only way your reasoning works is if quantum immortality is true, and we don't know if it is. There have been documented cases of people who believed in quantum immortality, attempting dangerous experiments to test it, people jumping off buildings, people putting themselves in extreme situations, believing that quantum mechanics would preserve their consciousness. From the outside perspective, these experiments failed. The people were badly injured or died. But from their perspective, if quantum immortality is real, they survived in other branches. They jumped and didn't hit the ground, or hit the ground, but miraculously survived with minimal injuries. Their consciousness filtered to the branch where they persisted. They experienced their own survival, even if everyone watching thought they were crazy and reckless. Which brings us to something deeply disturbing about quantum immortality. It's unfalsifiable. From your subjective perspective, you can never disprove it. Every time you survive something dangerous, you could interpret it as evidence for quantum immortality. You narrowly escaped a car crash. Evidence. You had a health scare that resolved. Evidence. You took a risk and it worked out. Evidence. But every time you survived through normal luck or normal circumstances, you would interpret it the same way. The theory becomes self-reinforcing. It feeds on itself. This creates what psychologists call a confirmation bias trap. Once you start believing in quantum immortality, once you start interpreting your survival through that lens, every coincidence becomes supporting evidence. Every narrow escape becomes proof. The theory becomes unfalsifiable, not just in principle, but in practice. Your mind starts filtering your experience to confirm what you believe. You stop noticing the times you narrowly avoided disaster and got lucky through normal chance. You start seeing quantum mechanical salvation. You start seeing the universe conspiring to keep you alive. And that belief could fundamentally change how you live. If you genuinely believe you can't die, if you believe the mathematics won't let your consciousness end, you might start taking risks you otherwise wouldn't take. You might stop being cautious about your health. You might believe that eating poorly or avoiding exercise doesn't matter because quantum immortality will save you anyway. You might put yourself in dangerous situations because you're convinced the universe will preserve you. And in the vast majority of possible worlds, if you're wrong about quantum immortality, that reasoning will kill you. Now here's where it gets really intricate. Because the question emerges, what if there are people alive right now who are quantum immortal? What if quantum immortality is real but you simply don't know it? How would you ever know? How could you distinguish between normal luck and quantum filtering? You can't. There's no test. There's no experiment that would conclusively prove you're in a survival branch rather than just a lucky normal branch. You'd accumulate experiences that could be interpreted as quantum immortality, but those same experiences could also be interpreted as statistical variance in a normal universe. Think about your own life. You've probably had moments that felt like uncanny luck, times when things worked out in ways that seemed impossible, car accidents you walked away from, illnesses that mysteriously resolved, dangerous situations that defused at the last moment. What if those weren't luck? What if those were your consciousness filtering toward survival branches? What if you're already quantum immortal and you've been experiencing it all along without realizing it? The more you think about that, the more you start to notice every coincidence, every near miss, every unexpected good fortune. They all start looking like evidence, and that's the psychological trap that quantum immortality creates. It's not just that the theory might be true, it's that there's no way to know if it's true. The uncertainty becomes infectious. It spreads through your interpretation of your own experience. You can't help but start filtering your life through that lens. You can't help but start noticing the survival, the lucky breaks, the narrowly avoided catastrophes. And once you start noticing them, once you start interpreting them as evidence, the belief becomes difficult to shake. This is why quantum immortality has started appearing in certain online communities. People discussing it seriously, people treating it as a genuine phenomenon that's already happening to them. Some people are genuinely concerned about becoming quantum immortal, worried about ending up in increasingly improbable branches of reality, worried about the isolation and the suffering that might come from it. Others are almost attracted to it, the idea that they're special, that they're being preserved by quantum mechanics, that they matter to the universe in some fundamental way. And neither of those responses is unreasonable given the theory. If quantum immortality is real, that's genuinely worth being concerned about. The prospect of eternal existence in increasingly damaged circumstances is horrifying. But if it's not real, if it's just a mathematical curiosity with no bearing on actual reality, then the concern becomes a kind of existential anxiety, a psychological trap where you're torturing yourself with a theory that probably isn't true, worrying about a fate that probably won't befall you. But here's what makes physicists genuinely uncomfortable about all of this. Even the physicists who are skeptical of quantum immortality, even the ones who think the theory has fundamental flaws, they can't make it go away. They can't prove it's false. They can find logical problems with it. They can identify mechanisms that don't work. They can point to the measure problem and the consciousness problem and the substrate problem, but they can't definitively prove that something like quantum immortality isn't happening. And that uncertainty hangs over the entire field, because if many worlds is true and evidence is trending in that direction, then the basic observation remains true. You will only ever experience realities where you continue to exist. That's not quantum immortality as Tegmark described it, but it might be something adjacent, something related, some phenomenon that emerges from the relationship between consciousness and quantum branching that we don't yet fully understand. And until we understand consciousness better, until we understand quantum mechanics better, until we figure out what the actual measure is and how to weight branches, and what role observation actually plays in reality, the uncertainty persists. Let me take you deeper into this, because we've been focusing mostly on what quantum immortality would mean for you as an individual, but that's actually the less troubling version of the problem. The truly disturbing aspect emerges when you start thinking about quantum immortality on a cosmic scale. What happens when you realize that if quantum immortality applies to you, it probably applies to everyone, every conscious being in the universe, all 8 billion of us, plus every being that's ever existed, plus every being that will exist. If the many worlds interpretation is correct and consciousness filters towards surviving branches, then every single conscious observer is performing this selection. Every person you've ever met, every person alive right now, every creature with subjective experience, they're all filtering toward branches where they continue to exist. They're all selecting for survival, and they're all doing it simultaneously in the same universe. Think about what that means mathematically. You need branches where you survive, but the people around you need branches where they survive too, and your survival branches need to be compatible with their survival branches if you're going to interact with them. So every quantum event, every branching, every splitting of reality has to somehow produce branches where all the conscious beings involved continue to exist together, or at least in overlapping realities. The computational complexity becomes absolutely staggering. The universe doesn't just have to maintain one survivor, it has to maintain billions of survivors simultaneously, each one selecting for their own survival, each one creating selection pressure on the branches. This is what some researchers call the observer conspiracy problem. Reality becomes a vast and intricate coordination problem. Every quantum event has to produce branches that satisfy the survival requirements of all the conscious beings involved. And those requirements might conflict. You want to survive, someone else wants to survive. You can't both survive in the same way if your survival requires mutually exclusive outcomes. So reality has to branching into versions where both of you survive, but in different ways, through different chains of events. The mathematical requirements become so complex that you start to wonder whether reality could even maintain consistency. You start to ask whether a universe with multiple quantum immortal observers could actually remain coherent. Could the laws of physics remain stable? Could causality remain functional? Or would the universe have to become increasingly malleable, increasingly adjusted, increasingly fictional? And here's where some cosmologists have started to raise a genuinely weird question. What if that's what we're already experiencing? What if our universe is already the result of observer selection effects? What if our reality has already been shaped by the requirements of consciousness? For decades, cosmologists have puzzled over something called the fine-tuning problem. The constants of physics, the fundamental numbers that determine how the universe behaves, they seem remarkably well suited for the existence of life, for complex structures, for conscious observers. If these constants were even slightly different, the universe would be radically different. Stars wouldn't form, atoms wouldn't be stable, chemistry wouldn't work, carbon-based life wouldn't be possible. The ranges are incredibly narrow. The precision is almost absurd. For example, the strength of the gravitational force compared to the electromagnetic force has to be tuned to about 1 part in 10 to the 36th power, 1 followed by 36 zeros. Change it slightly, and you don't get a universe capable of life. You get either a universe that collapses immediately, or one that expands so fast nothing ever forms. The same goes for the cosmological constant, the strength of nuclear forces, the mass-to-energy ratio of the early universe. All of these seem finely tuned. All of these seem carefully calibrated to allow for the existence of complex structures and life. For a while, physicists had various explanations, some religious, some anthropic, some invoking parallel universes with different constants. But quantum immortality offers an alternative explanation that's genuinely unsettling. What if the universe isn't finely tuned because someone tuned it? What if it's finely tuned because we're observing it from the inside? What if our universe has the constants it has because these are the constants compatible with conscious observers existing? Think about this carefully. If many worlds is true and quantum immortality is happening, then conscious observers are selecting for branches where they can exist. That selection pressure would act on the fundamental constants just as much as it acts on other quantum events. Branches where the constants allow for life would contain conscious observers. Those observers would experience their universe as real. They would perceive it as normal. They would be alive to notice it. Branches where the constants don't allow for life wouldn't contain conscious observers. Those branches would have no one there to perceive them, no one there to experience them as reality. So from the perspective of any conscious observer, their universe would always appear finely tuned for life. Because the only universes that would contain conscious observers to do the perceiving are universes that happen to be finely tuned. It's not that the universe was designed, it's that we could only possibly find ourselves in a universe that was capable of creating us. We couldn't possibly observe a universe incapable of supporting life because we wouldn't exist there to do the observing. This is called anthropic selection, and it's a legitimate scientific framework for thinking about certain cosmic questions. But quantum immortality adds a layer to it, because anthropic selection just says we'd observe a universe finely tuned for life. That's true whether many worlds is real or not. But quantum immortality says something more specific. It says that within a multiverse, conscious observers would select not just for branches where they can exist, but for branches where they continue to exist, branches where they survive the longest, branches where they remain conscious the most. And that selection pressure would shape the observable features of reality itself, which means our universe, the one we're observing right now, might already be a product of quantum immortality effects. The constants might be what they are not because of random chance or divine design, but because conscious observers throughout cosmic history have been selecting toward branches where those constants maintain consciousness, where they maintain observers, where reality continues to produce creatures capable of experiencing it. If that's true, then we're not looking at the natural universe. We're not studying how reality naturally unfolds. We're studying a universe that's been shaped by the feedback from conscious observation, a universe that's been filtered by the requirements of consciousness across billions of years of cosmic evolution. And that means everything we've learned about physics, everything we've discovered about the laws of nature, it might all be contaminated by observer selection effects. We might be blind to 99.99% of the multiverse, observing only the infinitesimal fraction of branches that's compatible with our survival, studying the laws of nature as they appear in the one pocket of the multiverse where creatures like us can exist. And everywhere we look, everything we measure, every discovery we make could be reflecting the fine-tuning required for observers to exist, rather than reflecting fundamental features of reality itself. Some physicists have started to wonder whether certain puzzling features of our universe might be symptoms of observer selection pressure, the accelerating expansion of the universe, for instance. Cosmologists discovered a few decades ago that the universe isn't just expanding, it's expanding faster and faster. Some mysterious force called dark energy seems to be driving this acceleration, but the strength of dark energy seems oddly calibrated. Too weak and the universe would collapse, too strong and it would tear itself apart immediately. As it stands, it's just strong enough to produce a universe where structure can form, where galaxies emerge, where observers eventually arise. What if that calibration is observer selection? What if our consciousness, looking backward through time, is selecting for branches of the multiverse where dark energy has exactly the right strength to allow us to exist, where the universe expands at just the right rate? What if the physical constants themselves are being held in their current state by the fact that they're compatible with our observation? This leads to what some researchers call the reality saturation problem. As more and more conscious observers accumulate in the multiverse over time, as observers continue to emerge in different branches, the selection pressure increases. Reality becomes increasingly constrained. Every possible event has to be filtered through the requirements that conscious observers continue to exist. Eventually, the constraints become so severe that reality can't evolve naturally anymore. It becomes locked in place, frozen by the mathematical requirements of universal immortality. Picture a universe where every random event, every quantum fluctuation, every particle decay has to be carefully orchestrated to preserve countless immortal consciousnesses, where natural stellar evolution is impossible because any change might threaten an observer, where galaxies can't form naturally because the process would interfere with someone's survival somewhere, where the universe becomes essentially static, maintained in an artificial state purely to sustain consciousness. In such a universe, physical law becomes negotiable. The laws of nature become suggestions that can be violated whenever necessary to maintain consciousness. Causality becomes optional. The very fabric of space-time could warp around the impossible requirements that observers continue to exist. Robin Hanson, an economist and philosopher who studies these scenarios, calls quantum immortal beings reality parasites. They consume vast resources from the multiverse. They force the universe to maintain increasingly complex and improbable states simply to keep them conscious. The energy requirements alone are mind-bending. Every miraculous survival, every impossible coincidence, every reality-bending event required to preserve consciousness has to come from somewhere. Energy has to be conserved. Work has to be done. That work requires fuel. And where does that fuel come from? From the universe's energy budget, from the available resources of the cosmos. As more observers accumulate and require more increasingly improbable survival circumstances, the universe would have to dedicate more and more of its energy to maintaining them. This creates what physicists call the heat-death acceleration problem. Eventually, all universes reach heat death. They reach maximum entropy, a state where no more useful work can be performed. Everything is evenly distributed. No energy gradients exist. No structure remains. It's the final fate of all universes according to current cosmological models. But if observer selection is happening, if conscious beings are demanding increasingly improbable survival, the universe might reach heat death much faster than current models predict. Imagine a cosmos where most energy is consumed not by stars and galaxies and the natural processes of cosmic evolution, but by the quantum mechanical maintenance of impossible consciousness, where the universe becomes essentially a vast life support system for immortal beings who should have died eons ago, where natural cosmic structures, stars, planets, galaxies, become secondary to the primary purpose of maintaining consciousness. Eventually, all that energy gets used up. The universe reaches its end state faster than it should. Heat death arrives sooner. The cosmos winds down and dies prematurely due to the burden of supporting quantum immortal observers. But here's what's genuinely terrifying about this scenario. We might already be living in it. We might already be in the later stages of a universe that's been drained by observer selection effects. We might be observing strange features in cosmology, the accelerating expansion, the properties of dark energy, the apparent fine-tuning, because our universe is already showing symptoms of observer selection pressure. We might be the inhabitants of a cosmic intensive care unit, kept alive by machines we can't see or fully understand. Some physicists have started to notice what they call anthropic shadows in the data, patterns that seem to hint that reality has been shaped by observer requirements rather than by natural processes. The distribution of galaxies, the formation of large-scale structure, certain features of cosmic radiation, they could all be explained by natural processes, but they could also be explained by observer selection. And the two explanations are actually difficult to distinguish observationally, which means we're in a position of genuine uncertainty. We don't know if we're studying a natural universe or a universe that's been shaped by consciousness. We don't know if our observations are revealing fundamental features of reality or revealing the filtered view of reality as seen from inside a selection bubble created by observers. Every experiment we run, every measurement we take, could be contaminated by observer selection effects that we can't identify or eliminate. Think about that for a moment. Everything physics has learned, every law of nature we've discovered, every principle we've formalized, it could all be reflecting not the fundamental nature of reality, but the particular shape of reality that's compatible with our existence. We could be blind to the true laws of nature, observing only the distorted version that filters through the observer selection bubble, looking at a universe shaped by consciousness, not a universe shaped by physics. And what makes this genuinely psychologically disturbing is that we can't know. We can't measure our way out of it. We can't devise an experiment that would prove whether observer selection is happening or not, because any experiment we could possibly run, any observation we could possibly make, would be conducted by observers, and observers always find themselves in branches where they continue to exist. So by definition, any reality we could possibly observe would appear to be shaped by observer selection. Even if it wasn't, we're trapped in an epistemological prison. We can observe a universe that appears fine-tuned for life, but we can't know if it's fine-tuned because of physics or because of consciousness. We can notice patterns in cosmology that look like observer selection effects, but we can't know if they're real or if we're just pattern matching. We can't get outside our own existence to look at reality from the outside. We can only look from within the bubble, from within the selection effect. And from within the selection effect, everything always appears to be selected. This is where quantum immortality becomes not just a theory about individual survival, but a comprehensive rethinking of what reality actually is. If consciousness shapes reality through observer selection, if multiple conscious beings are all performing their own selections simultaneously, if the universe is constrained by the requirements of maintaining all of them, then reality becomes something fundamentally different from what we thought. It becomes a negotiation, a coordination problem, a vast collaboration between conscious observers to maintain a shared universe where they can all continue to exist. And that's beautiful in a way. It's terrible and horrifying, but also beautiful. It suggests that consciousness isn't separate from the universe, that mind and matter aren't divorced from each other, that the universe itself might be fundamentally responsive to conscious observation, that reality and experience might be woven together more intimately than science has traditionally assumed. But it's also deeply unsettling, because it means we might not be discovering the laws of nature so much as we're discovering the requirements for consciousness to persist. We might be looking at a universe that's optimized not for any kind of objective truth, but for the continuation of awareness, for the maintenance of experience. The universe becomes less like a machine following deterministic physical laws and more like a living system oriented toward the preservation of consciousness. Let me bring this back to something personal, because we've been discussing cosmic implications and mathematical abstractions. But quantum immortality lives in your mind. It lives in how you interpret your own experience. It lives in the stories you tell yourself about why you're still here. And understanding that is where things become genuinely unsettling on a psychological level. Imagine you truly believed in quantum immortality. You read everything we've discussed. You understand the many worlds interpretation. You grasp the logic. You accept that consciousness filters towards surviving branches. Now you're going about your daily life with that knowledge embedded in your mind. And suddenly every moment becomes charged with a different meaning. You're driving on the highway. Traffic is heavy. Someone cuts in front of you. Your reflexes kick in. You swerve. The car behind you doesn't react in time. There's a collision. It happens inches from you. Vehicles spin out. You manage to keep your car under control. You pull over. Your hands are shaking. Everyone involved is okay. It was close, incredibly close. You sit there thinking about what almost happened. You think about how you almost died. But now you have a new interpretation available. What if you didn't almost die? What if you died in countless branches? What if right now, in most of the multiverse, versions of you are in hospitals or morgues? What if your consciousness filtered to the one branch where your reflexes were quick enough? What if the universe just saved you through quantum mechanics? What if you're experiencing quantum immortality right now? A week later, you get a medical test result back, something abnormal. The doctor wants to investigate. You're worried. You go through some additional testing, tests that are stressful, tests that carry their own risks. And then the final result comes back. It was a false positive, a labeling error. You're fine. You were never sick. Another narrow escape, another improbable outcome, another situation where something bad could have happened but didn't. Now your mind is connecting these events. The highway near miss, the medical scare. You remember other things, times you got lucky, times things worked out despite long odds, times you narrowly avoided disaster. With quantum immortality in your mind, you start to see a pattern. You start to interpret your life through this new lens. You're quantum immortal. The universe is keeping you conscious. Reality is bending around you to maintain your awareness. And here's where it becomes psychologically insidious, because you can't disprove it. Every piece of evidence you find can be interpreted as supporting the theory. Every coincidence, every fortunate outcome, every time something bad doesn't happen to you, all of it becomes evidence. The theory becomes self-reinforcing. It feeds on your own experience. It becomes woven into how you understand your own existence. Some people reach a point of acceptance with this idea. They think, well, if I'm quantum immortal, then I don't need to worry about certain things. I can be more reckless. I can take more risks. The universe will preserve me anyway. They start to make decisions based on the assumption that quantum mechanics will always save them. They might eat poorly, thinking their health will be maintained by quantum effects. They might drive carelessly, thinking accidents won't be fatal. They might put themselves in dangerous situations, believing they're protected. And if quantum immortality isn't real, that reasoning will kill them. In the vast majority of possible worlds, the branches where quantum immortality isn't true, if you live like you're unkillable, you'll die. You'll die young. You'll die from preventable causes. The only way your reasoning works is if quantum immortality is true. The only way your risk-taking doesn't backfire is if the mathematics really does guarantee your survival. And we don't know if it does, but there are other people who reach a different conclusion. They understand quantum immortality and they become genuinely frightened. They realize that if the theory is true, they can't escape. They can't choose to die. They can't opt out of existence. Even if life becomes unbearable, even if they want to end it all, they can't. Their consciousness would filter to branches where they survived the attempt. They'd be forced to continue, forced to exist, trapped in an existence that persists regardless of whether they want it to. This creates what you might call an existential imprisonment. You're locked into consciousness. You can't escape through death, because consciousness selects for survival branches. You're bound to keep existing, keep experiencing, keep being aware. And if life becomes suffering, if existence becomes unbearable, you have no exit. You're trapped forever in a universe that won't let you leave. There's also what researchers call the authenticity crisis. If you genuinely believe you're quantum immortal, if you believe reality is being shaped to maintain your consciousness, then at what point does your life cease to be genuinely lived and become something else? When the universe has to constantly intervene to keep you conscious, are you still living? Or are you existing in a kind of artificial simulation, a constructed reality designed to maintain awareness rather than to reflect any kind of natural unfolding? Think about the relationships you have, the people you care about. If quantum immortality is real, those relationships are maintained only because they're compatible with your survival. Your spouse exists in your reality because their presence helps maintain your consciousness. Your children exist in your version of events because they're part of the structure required to keep you aware. Your friends, your family, your community, all of it potentially exists because the universe needed it to exist to maintain your observation. Does that change what those relationships mean? If the person you love only exists in your reality because quantum mechanics required them to exist to keep you conscious, are they real? Are they their own being with their own independent existence? Or are they components of your personal survival infrastructure? Are they conscious beings in their own right? Or are they part of the artificial scaffolding that maintains your awareness? This creates what some philosophers call the authenticity question at the heart of quantum immortality. If your survival requires increasingly artificial circumstances, at what point does your existence become fundamentally artificial? If reality must constantly bend itself to keep you conscious, are you living in genuine reality or in a hallucination? Are your experiences real, or are they just the output of mathematical processes designed to maintain consciousness? And then there's the memory problem. This is something that really gets under people's skin when they think about it. If quantum immortality involves your consciousness jumping between branches to survive, if your awareness is filtering through parallel realities, could your memories be contaminated by experiences from other branches? Could you remember things that never happened in your current timeline? Could you carry forward knowledge and experiences from versions of events that exist in different parts of the multiverse? Imagine remembering a conversation with someone that they have no memory of. Remembering discussing something with a friend that, from their perspective, never happened. You have a clear memory of it. You're certain you talked about it, but they deny it. They have no recollection. Now you might think you're misremembering. Your memory is faulty. But what if you're not? What if you're remembering something from a parallel branch? A version of that conversation that happened in a different part of the multiverse and somehow bled through into your memory. This is what one researcher calls experience pollution. Your consciousness becomes contaminated with memories and sensations and knowledge from parallel branches where different versions of events occurred. You might remember having experiences you never had. You might feel emotions about events that didn't happen. Your sense of personal history becomes a confused mixture of timelines. Your memories become unreliable guides to what actually occurred because they're drawing from multiple realities simultaneously. How could you possibly maintain a coherent sense of identity in that situation? How could you know which version of your past is real? How could you have stable relationships with people if you're remembering different versions of shared events than they remember? How could you make decisions about the future if your understanding of the past is fragmented across multiple timelines? There's also what psychologists call the moral hazard problem in quantum immortality scenarios. If you genuinely believed you were quantum immortal, how would that change your ethical decision-making? If you believed the universe would always find a way to preserve your consciousness regardless of what you did, would you have any incentive to be cautious? Would you have any incentive to avoid harming others if your own survival was guaranteed? Someone who believes in quantum immortality might reason that taking drugs is fine because quantum mechanics will preserve their health, or that reckless behavior is acceptable because they can't actually die, or that they can take risks that endanger other people because the universe will save them. And while they're being saved, what happens to everyone else? What happens to the people around them who aren't quantum immortal, who don't have the same mathematical protection? The belief in quantum immortality could fundamentally alter your behavior in ways that are dangerous, not just to you, but to others, because you'd be operating under a completely different set of assumptions about how reality works, and what protections you have. And those assumptions could drive you to do things that would be lethal if quantum immortality isn't real. Some researchers have documented cases where people actually tested these beliefs. People who decided to prove quantum immortality by putting themselves in dangerous situations, jumping off buildings, driving at extreme speeds, putting themselves in situations designed to be fatal under normal circumstances. From an outside perspective, these experiments usually ended with injury or death. But from their perspective, if quantum immortality is real, they survived. They jumped and landed differently. They drove into a crash, but miraculously survived. Their consciousness filtered to the branch where they made it. And that's the unfalsifiable nature of quantum immortality again. If someone tests the theory by doing something suicidal and dies, an observer might say, well, that proves quantum immortality is false. They died. They didn't survive. But the person who tested it, if they survived, might say, well, of course I survived. I'm quantum immortal. The universe saved me. And an outside observer has no way to know which is true. Did they jump off a building and die? Or did they jump and somehow survive in an improbable way? Did they test quantum immortality? Or did they test human mortality? There's no way to know from outside their subjective experience. This creates a kind of epistemic quicksand around quantum immortality. The more you believe in it, the more evidence you find for it. The more you interpret your survival in terms of it, the more you see the theory confirmed in your own life, but the more trapped you become in the belief, because there's no way out, no way to disprove it, no test you can run that would convince you the theory is false if you've already committed to believing it's true. Now here's what makes this genuinely concerning from a mental health perspective. There's real documented evidence of people whose anxiety and depression have worsened after learning about quantum immortality. People who can't stop thinking about it, who start interpreting their entire existence through this lens, who become obsessed with the possibility that they're trapped in some kind of quantum cage, that they can't actually die, that they're forced to live forever. That reality is manipulating them to maintain their consciousness. Some people develop what you might call quantum immortality anxiety. They become hyper-aware of near misses. Every close call becomes potential evidence that they're quantum immortal. Every time they narrowly avoid disaster becomes a trigger, because they can't stop wondering if they're trapped, if they're already experiencing the filtered existence that quantum immortality describes, if they're already becoming isolated in increasingly improbable branches of reality without knowing it. Others become preoccupied with the idea that they might be trapped with no way to escape, that suicide wouldn't work because they're quantum immortal, that they could never achieve peace through death because consciousness would just keep existing in other branches. They experience a kind of existential terror at the thought of being forced into eternal existence whether they want it or not. And here's what's important to understand. These psychological responses are genuine. These people aren't irrational. They're not crazy. They're responding to a genuinely disturbing theoretical possibility with natural human anxiety. They're thinking through the implications of a mathematical model and arriving at terrifying conclusions. The fact that quantum immortality probably isn't real doesn't make their psychological distress any less real, but it also raises a question about the responsibility that comes with discussing these ideas. Is it ethical to present quantum immortality as a serious possibility without adequately addressing the psychological consequences of genuinely believing it? Should we be promoting these ideas more widely if we know they can trigger anxiety and distress in vulnerable people? These are real questions that philosophers and scientists are starting to grapple with, because quantum immortality occupies this strange space where it's intellectually interesting but psychologically dangerous. It's mathematically coherent but experientially terrifying. It's based on legitimate interpretations of quantum mechanics, but leads to conclusions that might be harmful. It's a thought experiment that's starting to become a genuine source of existential anxiety for some people, and we don't really have a good framework for dealing with that yet. The bottom line is that understanding quantum immortality changes something in how you experience your own existence. It's hard to fully unthink it once you understand it. You start noticing your own survival, your own luck, your own narrow escapes, and you wonder. You can't help but wonder, is it luck or is it something else? Is it quantum mechanics keeping you conscious, or is it just statistics? Is your life real, or is it an artificial construction designed to maintain awareness? And that wondering, that uncertainty becomes a permanent feature of your psychology. Once you've truly understood the theory, you can't unsee it. You can't go back to a time before you understood it. You carry it with you, and sometimes it weights you down. So where does this leave us? We've explored quantum immortality from multiple angles. We've seen the mathematical foundation. We've examined the scientific critiques. We've considered the cosmic implications. We've looked at the psychological effects. But we haven't really addressed the central question directly. Why does this theory persist? Why do serious physicists keep thinking about it despite all the problems? Why can't we just dismiss it and move on? The answer is that quantum immortality persists because it forces us to confront something we've been avoiding in physics for over a century: the measurement problem, the role of observation in quantum mechanics, the fundamental question of what consciousness is and how it relates to physical reality. These aren't new questions. They've been around since the very beginning of quantum theory. But quantum immortality makes them impossible to ignore. See, for most of the 20th century, physicists had a kind of truce with the measurement problem. They decided not to think about it too hard. They developed mathematical formalism that worked. They made predictions. They ran experiments. The predictions matched the experiments. So they didn't worry too much about what was actually happening at the foundational level. They didn't worry about what made an observation special. They didn't worry about what happened to the wave function when you weren't looking. They just used the rules and got results. But that truce was always fragile, because the measurement problem is genuinely strange. It suggests that consciousness plays a special role in physics, that observation affects reality, that the act of looking changes what you're looking at. For a long time, physicists tried to explain this away. They said the observer effect doesn't require consciousness, that any measurement apparatus, any physical interaction constitutes an observation, that consciousness doesn't need to be involved. But quantum immortality resurrects this question in a way that's hard to ignore. Because if many worlds is true, if all outcomes actually occur, then what does observation mean? What does measurement do? The math of many worlds doesn't require an observer. It doesn't require consciousness. The branching happens regardless. But then quantum immortality comes along and suggests that while consciousness doesn't create the branching, consciousness might be sensitive to it. Consciousness might be able to exploit it somehow. Consciousness might be able to filter through the branches, and that's where neuroscience becomes relevant, because we genuinely don't understand consciousness. Despite enormous progress in brain imaging and neuroscience over the past few decades, we still don't know what consciousness fundamentally is. We don't know how subjective experience emerges from neural activity. We don't know why the physical processes of the brain produce the feeling of being you. We call this the hard problem of consciousness. And it's hard precisely because it seems to resist scientific explanation. Some neuroscientists believe consciousness is purely an emergent property of complex neural networks, that it's what billions of neurons doing their thing looks like from the inside. But other researchers point out that emergence doesn't fully explain subjective experience. You can understand everything about how neurons work. You can map every connection. You can understand the electrochemistry. You can predict behavior perfectly. And you still wouldn't understand why there's something it feels like to be conscious. Why the experience of seeing red is the way it is. Why you experience being you instead of being nothing. This gap in our understanding leaves room for alternatives. Some researchers have proposed quantum biological processes might be involved in consciousness. Stuart Hameroff and Roger Penrose have developed theories suggesting that quantum processes in microtubules within neurons might play a role in generating consciousness. Their ideas are controversial. Most neuroscientists think the brain operates at a level where quantum effects would be washed out by thermal noise, but the fact that serious researchers are exploring quantum effects in consciousness shows that the field hasn't completely closed the door on the possibility. There's also emerging research on altered states of consciousness. During meditation, during psychedelic experiences, during sleep, consciousness seems to behave differently. The boundaries of the self seem to dissolve. People report experiences of interconnectedness, of accessing knowledge they shouldn't have, of perceiving reality differently. Most neuroscience explains this in terms of altered neural activity, changes in brain chemistry, reduced activity in the default mode network. But some researchers wonder if something else might be happening, if consciousness might be more fundamental than neural activity, if the brain might be a receiver or filter for consciousness rather than a generator of it. Now, I want to be clear that these ideas remain speculative. They're on the fringe of mainstream neuroscience. Most neuroscientists would dismiss them, but they exist precisely because consciousness remains mysterious. And mysteries are where quantum immortality thrives, because quantum immortality is, at its core, a question about consciousness, about what consciousness is, about how it relates to physical reality, about whether it can survive physical death, about whether it can persist across different branches of the multiverse. And here's where things get genuinely interesting. In the past few years, some physicists have started to take seriously the possibility that consciousness might play a more fundamental role in physics than previously thought. There's a framework called objective idealism, which suggests that consciousness might be fundamental to the universe. That physical reality might emerge from consciousness rather than consciousness emerging from physical reality. It sounds crazy, it sounds unscientific, but it's being explored by legitimate physicists trying to make sense of quantum mechanics. If consciousness were fundamental, if it were a basic feature of the universe like space and time and energy, then the measurement problem might have a different solution. The observer would be special precisely because consciousness is special. The wave function would collapse when observed because observation involves consciousness interacting with physical systems. And quantum immortality would make more sense. Your consciousness could persist across branches because consciousness is fundamental, because it's not bound by the usual rules of matter and energy, because it could potentially do things that seem impossible from a purely physical perspective. Now, most physicists find this deeply uncomfortable. They spent the 20th century trying to remove consciousness from physics, trying to make physics objective, trying to explain everything in terms of physical law without reference to observers or consciousness. The idea of putting consciousness back into physics feels like a step backward, like going back to ancient mysticism, like abandoning scientific rigor. But quantum immortality forces the question. If consciousness only ever experiences realities where it persists, if consciousness can only find itself in branches where it continues to exist, then consciousness is doing something. It's selecting something. It's responsive to the structure of reality in some way. One of the most interesting recent developments in quantum physics is something called quantum Bayesianism, or cubism. It's a framework developed by physicist Christopher Fuchs and colleagues, and it suggests that the wave function might represent not objective reality, but subjective personal experience. That quantum mechanics might fundamentally be about the beliefs and experiences of individual observers, rather than about objective features of the world. If cubism is correct, then quantum immortality takes on a new interpretation. Your consciousness doesn't select branches in an objective multiverse. Rather, your subjective experience of reality is structured by quantum mechanics in such a way that you always experience yourself as surviving. Your personal wave function, so to speak, always corresponds to branches where you continue to exist. This makes quantum immortality less about objective physics and more about the structure of subjective experience. It makes it more plausible in some ways and more unfalsifiable in others. Because if it's about subjective experience, then you can never prove it's false. You can never step outside your own experience to verify whether quantum mechanics is really selecting branches or whether it's just the way conscious experience is structured. You can only experience your own perspective, and from your perspective, you always exist, you always persist, you always continue to be conscious. There's also the question of whether quantum immortality might be true in a limited way, maybe not in the extreme form that Tegmark described, maybe not leading to centuries of suffering in increasingly improbable circumstances, maybe just in the sense that consciousness has some property that makes it stable, that makes it difficult to snuff out, that makes it persistent. Some researchers have suggested that consciousness might have what they call Darwinian properties, that conscious systems that are better at persisting might reproduce and spread, that consciousness might have evolved to be persistent, to be difficult to destroy, to find ways to continue existing. If that's true, then quantum immortality wouldn't require many worlds at all, wouldn't require consciousness jumping between branches, wouldn't require any exotic quantum mechanics, just the ordinary evolutionary principle that systems that are good at persisting will outcompete systems that aren't. Consciousness as a phenomenon has clearly been good at persisting over evolutionary time. Humans are still here, still conscious, still aware, despite countless threats and challenges. If consciousness has properties that make it persistent, if the universe is selected to preserve conscious systems, then in a sense something like quantum immortality could be true on purely evolutionary grounds. But that's also more limited and less disturbing than the quantum immortality we've been discussing. It doesn't require your individual consciousness to persist forever. Just that consciousness as a phenomenon is persistent, that living conscious beings continue to exist. That's not really quantum immortality in the sense that Tegmark meant it. That's just biology and evolution. Though it is interesting that the same instinct, the persistence of consciousness, appears in both evolutionary theory and in quantum immortality theory. Here's what genuinely troubles physicists about quantum immortality, though. It's that the theory, despite all its problems, points to something real. The many worlds interpretation, even if it has issues, seems to be gaining support from recent experiments. The measurement problem hasn't gone away. It's actually become more acute as we've learned more about quantum mechanics. Consciousness remains profoundly mysterious. We don't understand it. We don't understand how it emerges from physical processes. We don't understand what gives rise to subjective experience. We don't understand whether it might have properties or capabilities we haven't recognized. And quantum immortality sits at the intersection of all these mysteries. It's a theory that arises naturally from the mathematics of many worlds and the nature of conscious observation. observation. Even if the specific mechanisms don't work out perfectly, even if there are logical problems with how the theory is formulated, the core insight seems sound. If consciousness can only ever experience realities where it exists, then consciousness should tend to find itself in realities where it continues to exist. That's not a bug in the theory, that's a tautology. That's true by definition. So physicists can't dismiss quantum immortality the way they might dismiss other crackpot theories, because it's not obviously false, it's just obviously complicated. It's just pointing to genuine gaps in our understanding. It's raising questions about consciousness and reality that we don't yet have answers to. And those questions matter. They matter for understanding the fundamental nature of the universe. They matter for understanding what we are as conscious beings. They matter for understanding what might happen to consciousness if and when our bodies die. Which is why quantum immortality, despite all its problems, continues to haunt physics. It's not a solved problem that we can move past. It's an unsolved problem that keeps coming up. It's a question about the relationship between mind and matter that forces physicists to confront the limitations of their understanding. And sometimes the most important questions are the ones that make us uncomfortable, the ones that point to genuine gaps, the ones that suggest our current frameworks might be incomplete. Because here's what's true regardless of whether quantum immortality is real or not. Consciousness remains mysterious. The measurement problem remains unsolved. Many worlds remains one of the leading interpretations of quantum mechanics. And there's something profoundly strange about the structure of reality that suggests consciousness plays a more fundamental role than we've traditionally assumed. Whether that role involves quantum immortality specifically remains an open question. But the questions underlying quantum immortality are genuine questions. They're questions worth thinking about. They're questions that might eventually reshape our understanding of physics and consciousness and the fundamental nature of reality. And that possibility, the possibility that we're fundamentally misunderstanding something crucial about how consciousness and reality interact, that possibility alone is significant. That possibility alone justifies physicists taking quantum immortality seriously despite its problems. Because if quantum immortality is pointing to something real about the nature of consciousness, about how conscious systems interact with quantum reality, then understanding it could transform our understanding of everything. It could reshape how we think about death, about meaning, about the purpose of existence, about what we are. Let me bring us back to where we started. You remember, right? I asked you to tell me where you were watching this from, what time it was where you are, what the temperature was like outside. I asked because that connection between us, between you and me, across however many time zones, across whatever version of reality you're currently inhabiting, that connection was going to matter. And it does. It matters because we've just spent over 2 hours together exploring one of the most disturbing implications of quantum mechanics. And I wanted you to remember that you're real, that where you are right now is real, that the experience of being you in this moment is genuine, because that's what quantum immortality really challenges: your confidence in the reality of your own experience, your trust in the world around you, your understanding of what it means to be alive. It challenges you to sit with the uncertainty, to accept that we don't fully understand consciousness, to acknowledge that the relationship between mind and matter remains fundamentally mysterious, to recognize that physicists can't definitively prove quantum immortality is false, even though there are serious problems with the theory. And that uncertainty, that genuine not knowing, is something we all have to live with. I want to be honest with you about something. When I started exploring quantum immortality deeply, it did affect me. Knowing that every moment of my life where I could have died but didn't, I could interpret as quantum filtering. Knowing that I can't prove I'm not in an increasingly improbable branch of the multiverse. Knowing that consciousness remains mysterious enough that survival across realities isn't completely absurd. It changed how I think about my own existence. It made me more aware of my survival, more conscious of my consciousness, more grateful for being alive, actually, in a way that's hard to explain. But I also want to tell you that living with that knowledge becomes manageable. You can't let it paralyze you. You can't let the uncertainty overwhelm you, because whether quantum immortality is true or not, whether consciousness is fundamental to the universe or an emergent property of neural networks, whether you'll survive death or completely cease to exist, you still have to live your life right now. You still have to make decisions. You still have to treat people kindly. You still have to find meaning in whatever existence you have. And maybe that's the most important thing that quantum immortality teaches us. Maybe the real value of the theory isn't whether it's true. Maybe it's that it forces us to confront what we take for granted. The reality of consciousness, the mystery of existence, the fact that we're here, aware, experiencing, that we live in a universe that's fundamentally stranger and more wonderful than we usually admit. That consciousness, whatever it is, has managed to emerge in this cosmos, and that emergence is remarkable. If you accept that consciousness might be fundamental, if you accept that it might play a role in shaping reality, if you accept that your awareness might be something more than just neurons firing in your brain, then you start to see reality differently. You start to see yourself as more than just biological machinery. You start to see the universe as something that includes consciousness rather than something that just happens to produce consciousness as a side effect. And that perspective can be genuinely transformative. On the other hand, if you reject quantum immortality completely, if you're confident that consciousness is purely emergent and will end with death, if you believe the universe is ultimately mechanical and meaningless, then at least you have clarity. You know what to expect. You can plan accordingly. You can find meaning in the brevity. You can appreciate the preciousness of existence precisely because it's temporary. That perspective can be equally transformative in its own way. The key is not to be stuck in between, not to be paralyzed by uncertainty, not to let the mystery become an excuse for inaction or despair. The mystery is real, the uncertainty is genuine, but so is the present moment. So is the fact that you're alive right now. So is the fact that you can make choices. You can treat people with kindness. You can pursue things that matter to you. You can create meaning, regardless of what happens after death, regardless of whether consciousness persists or ends, regardless of whether we're in a natural universe or one shaped by observer selection effects. There's also something beautiful about not having final answers, because the moment you stop asking questions, the moment you stop wondering, the moment you fully accept one worldview as absolute truth, you become closed off. You stop growing, you stop learning, you stop being surprised by reality. But quantum immortality and all the questions it raises, it keeps you open. It keeps you asking. It keeps you wondering about the nature of consciousness and reality. And wonder, genuine intellectual wonder, is one of the best things human beings experience. Think about a child discovering the world for the first time. Everything is surprising. Everything is a mystery. The world is full of wonder and strangeness and things that don't quite make sense. As we grow up, we lose a lot of that. We accept explanations. We stop asking why. We move through the world with a kind of comfortable certainty that's usually wrong. Quantum immortality can bring some of that wonder back. It can remind you that we don't actually understand as much as we think we do, that the universe is stranger than our explanations, that consciousness might be something more remarkable than we've admitted. And if that's true, if consciousness is truly remarkable, if it's truly fundamental, if it truly plays a role in shaping reality, then you become remarkable too. Your existence becomes more significant. Your choices become more consequential. The fact that you're here, aware, experiencing, participating in the cosmos, that becomes genuinely important. Because consciousness might matter in the deepest sense. It might not just be an accident. It might be what the universe is fundamentally about. So here's what I want to leave you with. Two possibilities. Two ways of thinking about what we've discussed today. And you can choose which one resonates with you more, or you can hold both simultaneously. First possibility. Quantum immortality is false. The many worlds interpretation doesn't describe how reality actually works. Or if it does, consciousness doesn't survive across branches, or the mechanism doesn't work the way theorists suggest. In this case, death is real, final. You'll experience it eventually, and that should motivate you to live well right now, to do the things that matter to you, to spend time with the people you love, to create things that will outlast you, to find meaning in the here and now, because the here and now is all you really have. This perspective is liberating in its own way. It makes you prioritize what's actually important. Second possibility. Quantum immortality is true, or something like it is true. Consciousness does have properties we don't fully understand. It does interact with quantum reality in ways that preserve it across branches. Or awareness has some capacity to persist that transcends physical death. In this case, you have something like eternity ahead of you. But as we discussed, that eternity might not be pleasant. It might involve suffering in increasingly improbable circumstances. It might involve isolation. It might involve fragmentation. In that case, the question becomes how you want to spend that eternity. What kind of consciousness do you want to be? What kind of being do you want to become? And you know what? In both cases, the answer is the same. You should live well. You should treat people kindly. You should pursue things that matter. You should create. You should learn. You should love. Whether you have a limited time or unlimited time, whether consciousness ends or continues, whether reality is natural or shaped by observation, all of those questions lead to the same practical conclusion. Live meaningfully. Be the kind of being you'd want to continue existing as. Create the kind of reality you'd want to inhabit forever. That's actually the deepest insight of quantum immortality. It's not really about whether you'll survive death. It's about what kind of being you're becoming right now. Because if consciousness does shape reality through observation, then the consciousness you cultivate right now, the awareness you develop, the attention you bring, the perspective you embody, that consciousness is literally shaping the universe. That's not metaphorical. If quantum immortality is true, then your consciousness is an active force. You're not just observing reality. You're participating in creating it, and that's an enormous responsibility. So the last question I want to leave you with is this: if your consciousness really does shape reality through observation, if your awareness really is woven into the fabric of the cosmos, if you really are participating in creating the universe you inhabit, what kind of universe are you creating? What reality are you selecting for? Are you cultivating consciousness that's open or closed, curious or rigid, compassionate or cruel, grateful or resentful? Because whatever consciousness you develop right now, that consciousness might be eternal, that consciousness might persist, that consciousness might be what you experience forever. That thought right there, that might be the most important implication of quantum immortality. Not whether you'll survive death, but what kind of being you're becoming right now, how you're developing your consciousness, how you're shaping your awareness. Because that awareness, that consciousness, that being you're becoming, it might be all there really is. It might be eternal. It might be what continues. And if that's true, then you'd better pay attention to who you're becoming. I'm grateful you spent these hours with me. I'm grateful you traveled through this theoretical landscape with me. I'm grateful you thought about quantum immortality and consciousness and the nature of reality. Because your attention, your consciousness paying attention to these ideas, that matters. That's real. That's genuine. That's you participating in the cosmos in a meaningful way. And here's what I want from you now. If this has resonated with you, if you've found yourself thinking about quantum immortality differently after this journey, then share that. Tell someone about it. Write in the comments what you're thinking about, where you watched this from. Remember, you told me at the beginning. Tell me what you're thinking now. Tell me if you're more convinced quantum immortality might be real, or more convinced it's false. Tell me what scared you. Tell me what inspired you. Tell me what questions this raised for you. Because you can't just watch this and move on the same way you were before. You've spent 2 hours thinking about consciousness and reality and death and infinity. You've considered possibilities that most people never contemplate. You've asked questions about existence itself. That changes something in you. And I want to know what changed. I want to hear about your journey through this. I want to know that your consciousness, your unique perspective, your particular way of experiencing the world matters. Subscribe if you want to go deeper into these ideas. Because we're going to keep exploring. We're going to keep asking questions about quantum mechanics and consciousness and reality. We're going to keep pushing into the uncomfortable spaces where science meets philosophy meets the fundamental mystery of what we are. And if you want to be part of that journey, if you want to keep exploring these ideas with me, then subscribe. Hit the bell notification. Let YouTube know you want this content. And here's the last thing. Remember what I said at the beginning. I asked you where you were, what time it was, what the temperature was outside. I asked that because I wanted you to remember your own reality, your own particular branch of the multiverse, your own unique perspective on consciousness. And I want you to remember that now. Remember that you're real. Remember that your existence matters. Remember that your consciousness is remarkable. Whether quantum immortality is true or false, whether you continue after death or cease completely, right now, you are alive, you are aware, you are conscious, and that's enough. That's more than enough. That's everything. Thank you for listening. Thank you for thinking. Thank you for allowing your consciousness to explore these ideas. I'll be back soon with more deep dives into the strangest corners of physics and philosophy and the nature of reality itself. Until then, take care of your consciousness. Treat it kindly. Feed it with wonder. Nourish it with curiosity. Be the kind of being you'd want to be forever. Take care.